Good morning, everyone. Today I am going to present about the preparation of the tin sulfides, particularly metal chalcogenides from the metal oxide sources. My presentation contains the introduction and also the status of the solar cells and preparation of the metal sulfides from the metal oxides and the conclusion. So we know well these days there are two big challenges. One is energy generation and energy storage. So the reason for this is a greenhouse effect. If you see here, the global warming is a challenge, and the climate of the earth causing the heat up, and where the greenhouse effect is naturally occurring phenomena, constantly occurring due to the atmospheric and sunlight. Greenhouse effect and global warming, though closely associated and are different from each other, it causes the other issues in the effect. So the causes for the global warming are, the number one is fossil fuels and also vehicle exhaust and residual the waste and fertilizers. So there are several causes. If you see here, the transport and electricity generation, the industry and agriculture and commercial and residual. So if you see here, there are major contribution comes from the transport and the electricity generation and industry. So these are the three main causes for global warming. So the solution for this global warming is the power that means particularly solar energy, or use the solar related the electrical vehicles and recycle them as much as, and find the ways to develop the novel feeds for the agriculture. So I think solar energy is a good solution for the global warming. So here we are going to, I am going to present the benefits of solar energy and its the importance. Solar energy is renewable energy, and solar energy is easy to generate, and solar energy is non-polluting, and solar energy is infinite, so we can get it ultimate energy. So here is the estimation of the potential of solar energy. From this figure you can understand easily that the solar energy is more than anything, even compared to the coal or nuclear or oil or natural gases. This is a principle of, so it's better to utilize the solar technology either to produce electricity or the fuels. So here this is the principle of the solar cell working. When you eliminate the solar cell in the presence of light, it will generate the electrons and holes. So you can collect at the end. You can utilize this current directly, or also you can store this electrical energy in the another form. And in view of the solar cells, only the important factor is efficiency. We know everywhere efficiency is only the matter. So these are the actual parameter to evaluate the solar cell performance. So, and this is the circuit for solar cells. If you see here, initially the pipeline shows so wide, and it getting narrower. This is due to the various losses, so and the leakage point. So if you fill up these leakage points, if you are able to get the initial amount of energy in the outset, then we can reach our goal. These are the issues. So here I am going to show the efficiencies. These are the efficiencies of the various solar cells, CIGS and CDTE and silicon. These are the popular technologies over the past 20 years. Currently the perovskite solar cell is also the interesting, but showing a good efficiency. And here provide each technology some positive and negative aspect. The crystalline silicon solar cell, it shows the high efficiency, but however the cost and the price and the process temperature is higher. So as a result, inorganic compound solar cells such as CDTE and CAGS are developed alternative to that silicon solar cells. However, here also there are some drawbacks. Indium, gallium and tellurium is expensive and not abundant. At the same time, the toxicity of the cadmium and the tellurium limit the further development of this technology. Therefore, the alternative materials are still developing. So among them, recently the organic and perovskite solar cell has shown the prominent performance. However, this will suffer the most. The problem is stability. So by recognizing these limitations of the existing materials, there is a need to develop the breakthrough for the new materials. You can see here there are 4 factors: the material aspect, process and efficiency and stability. So I will show the alternative to these issues. If you see the perovskite case, the stability is the problem, and if you look at for CAGS and CDTE, the material aspect is actually the problem. In case of CZTS solar cell, the process is actually the complex. So therefore, we should develop the alternative process to develop the photovoltaic materials, as well as we should find the feasible method and material. So these are the key issues in this technology: the process and material. Still there is a chance to develop and the selection of the new material process is like this. Number 1 is it should be cheap and generic material and non-toxic and smaller elements, and also the electrical and optical properties of the material should be suitable for solar cell application. It should have long-term stability. These are the 4 important selection factors for the new material. So the way is here the price, and these are the different alternative materials. Even though CZTS and copper tin sulfide or antimony or iron sulfide are promising, but the problem with iron sulfide is there exist several secondary phases. Similarly, in case of copper tin sulfide or copper zinc tin sulfide case also same, there are several phases. It is difficult to form the single phase. And in case of tin monosulfide and selenide or antimony sulfide and selenide, there are less number of phases, and these are promising. So the properties of these 2 materials are the band gap of the either antimony or tin related chalcogenides is 1 to 1.5, and this has high absorption coefficient, and this material shows the p-type conductivity and resistivity is in the range of 100 ohms, and the whole carrier concentration and diffusion length is reasonable, and constitution elements are abundant in the nature and do not cause us any problem, and the efficiency of these materials higher. Therefore, we can work on tin or antimony related materials. This is the current state of the existing earth abundant material efficiency state. If you see here, tin sulfide or antimony sulfide related materials show the reasonably good efficiency. And preparation of now I am going to discuss about how to prepare the metal sulfides and metal oxides, and why should we do this process. So if you look at this picture, we prepared these tin sulfide films using sputtering and sulfurization process. There the metal layers were deposited first using sputtering and then sulfurized. If you look at these 2 pictures, you can find lot of pinholes and a non-uniform surface. So before going to this 2-stage process, there are several techniques: spray pyrolysis, chemical bath and other techniques, but those techniques are not feasible for the industrial application. Among the different techniques, 2-stage process particularly sulfurization or salinization are promising methods to develop the absorber layer for solar cell application. So we intended to develop the solar cell by two-stage process. As a first, we prepared the tin metal layers by sputtering, and then we sulfurized. But we try to adjust the various parameters, temperature, time, and also the pressure of the sample preparation conditions. However, always the surface showing the non-uniformity, and also there are several voids. So therefore, we intended, because another the big issue here is the expansion of the, during the sulfurization, there is uneven expansion of the metal layer, as it causes the surface and also the between the substrate and the film, there are some voids. Therefore, we realized maybe the oxide layers will provide the prominent path to reduce these surface problems, and also the voids in the and also the gap, the voids between the substrate and the absorber layer. Therefore, we intended to sulfurize the tin oxide films in the sulfurization process. So this is the reason for developing this process. So first, there are many pinholes in the samples, and also the surface is not uniform. So controlling of the uniformity and the surface is more harder in case of metal sulfurization. Therefore, we try to deposit the metal oxide layers for sulfurization. The first, we prepared the tin oxide layers by using sputtering process. Here we prepared 500 nanometer tin oxide by using sputtering, and then the sputtered tin oxide layers and also the sulfur plates together keep inside the graphite box, and then loaded into the quartz tube and then annealed. So we expected the process of the mechanism as here. So here the legends oxygen indicates the color, and sulfur and tin. So tin oxide we thought it will replace, and we did several experiments at a different temperature and a time period and also pressure. But still it is not close to form the tin monosulfide. We obtained either a tin oxide with tin sesquiosulfide or a tin disulfide with tin sesquiosulfide, but we intended to develop the tin monosulfide for the solar cell application. So later we realized that the formation energies of these compounds. So if you see here, the tin oxide will form more easily as compared to the tin sulfide. We need a really high temperature and also the special conditions for the tin monosulfide. Even when we attempted to prepare the tin sulfide using metal layers, that time also it is so hard to find the really suitable area to form the tin monosulfide. This process is also seems to be similar. We tried the wide range of temperature from room temperature to around 550 degrees, but still we are unable to form tin monosulfide. Instead, we are getting either tin disulfide or the other phases. So after the preparation of the layers, we measure the EDS. From the EDS, we confirmed the sulfur incorporation in the layers, but still there is some portion of the oxygen in case of the less amount of sulfur presence. Whenever we added more sulfur, so we almost reduced the oxygen presence, and we are able to produce tin disulfide instead of monosulfide. But at the same time, yes, still we are struggling, but to prepare the good surface, but it is a little bit more better than as I showed in the first these things. And so still we are not really find the exact conditions for tin monosulfide. We are working on that. Hope we will change the other parameters. Soon we will get the monosulfide from this tin dioxide, but I realized more tin monoxide is more suitable precursor for preparation of the tin monosulfide. From tin dioxide is more difficult to form the tin monosulfide. So maybe we will plan to develop the tin monoxide and then sulfurization. So this is our future plan. Because of some limited time and the facilities, and there are some technical issues while preparing. I am sorry I am not able to show the more data about this. Hope in the future I can show more result. Thank you. Thank you so much.
네, 혹시 질문 있으시면 질문 주시면 감사하겠습니다. I have quick question.
Yes, please.
I think you tried to convert tin oxide to tin sulfide.
Yes, tin
by
monosulfide.
the sulfurization at some higher temperature.
Yes.
Have you tried to characterize the substrate? I just wondering if there is some doping problem on the substrate.
So the left side graph is the tin oxide substrate is okay. So we use the glass substrate currently.
Okay. So will you use the glass for your application?
Actually, we will deposit for solar cell application on the molybdenum substrate. So if I try to utilize molybdenum substrate, more complications. Is nobody tried this manner. So first I would like to see the reaction mechanism of the sulfur with the tin oxide. So first initially I am planning to study on the glass substrate. Once I understand the reaction mechanism, then I will plan to prepare on the molybdenum substrate. So if I go directly, I may have more complications. Sometimes oxygen will diffuse into the molybdenum, so the molybdenum oxide will form or some other issues will come. First, at least I should be familiar with the reaction mechanism of tin oxide and sulfur, then I will go on the molybdenum substrate.
Thank you.
Thank you so much.
혹시 질문 있으실까요? 네, 질문 없으시면 마무리를 하도록 하겠습니다. Thank you very much.